Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Deployment models define the location of computing infrastructure and determine which party is responsible for its operation and upkeep. The three primary deployment models are on-premises, public cloud, and hybrid cloud. Each has different impacts on control, cost, and accessibility, and the exam may require you to compare them based on these attributes. Selecting the correct deployment model is essential for meeting compliance requirements, achieving scalability goals, and maintaining adequate security. On-premises deployment means that all computing resources are hosted, managed, and maintained locally by the organization itself. The hardware is physically located on company property, often in server rooms or dedicated data centers. This arrangement gives the organization complete control over the systems, their configurations, and all related security policies. On-premises environments are often chosen by organizations with strict regulatory requirements or performance needs that demand tight control. The main advantages of an on-premises approach include complete control over infrastructure and stored data. Internal access does not rely on an external internet connection, which can reduce downtime risk. Hardware and software configurations can be fully customized to meet exact requirements. Organizations with strict compliance obligations may also find it easier to satisfy them when infrastructure is kept entirely on-site. The disadvantages of an on-premises model include the high upfront cost required for hardware, physical facilities, and power. It also demands a dedicated internal IT staff to handle maintenance, upgrades, and security management. Scaling the environment can be slow and inflexible compared to cloud options. Finally, the need to replace or refresh hardware over its lifecycle adds additional operational complexity. Public cloud deployment is when a third-party provider hosts and manages the computing infrastructure in remote data centers. Customers access resources over the internet using a pay-as-you-go model. These resources can include virtual machines, storage capacity, and complete software platforms. Examples of public cloud providers include Amazon Web Services, Microsoft Azure, and Google Cloud Platform. The advantages of public cloud include lower upfront costs and the ability to scale resources quickly as needed. There is no requirement to maintain or operate physical servers on site. Customers can take advantage of a provider's global infrastructure and built-in high-availability capabilities. Public cloud services can also be deployed rapidly, making it easier to test or expand environments on demand. Disadvantages of public cloud include reduced control over hardware and data location. An internet connection is always required to access cloud resources. Costs can become unpredictable if usage is not monitored closely. Additionally, the shared infrastructure model can create security concerns if access controls and configurations are not properly managed. Hybrid cloud deployment combines both on-premises and public cloud resources within a single operational framework. This allows organizations to maintain control over sensitive systems while also taking advantage of the flexibility and scalability of cloud resources. Data and workloads can be shifted between the two environments as needed. Hybrid cloud is common in industries that have requirements for data sovereignty, availability, or specific compliance frameworks. The main advantages of a hybrid approach include a balance between flexibility and control. It allows for cloud-based scalability while still maintaining legacy systems on site. Hybrid setups can support disaster recovery strategies that use the cloud as a backup location. This approach also supports gradual migration from on-premises infrastructure to cloud services without forcing an abrupt change. The disadvantages of hybrid cloud include increased complexity in configuration and management. It requires integration of networking, authentication, and monitoring tools across both environments. There may be compatibility challenges between on-premises systems and public cloud platforms. Misconfigurations or inadequate security across these linked environments can increase the risk of breaches or downtime. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Selecting the correct deployment model depends on an organization's security requirements, budget constraints, scalability needs, and compliance obligations. An on-premises model is best when sensitive data or complete control is required. Public cloud deployment is better suited for workloads that must scale rapidly and be deployed quickly. Hybrid cloud offers the most flexibility for organizations that want to combine these advantages while addressing both technical and regulatory needs. Real-world examples of on-premises use include a hospital that hosts electronic health records locally to comply with health privacy laws. A financial firm might operate proprietary trading algorithms on secured internal servers. A manufacturing plant could run air-gapped systems for production reliability. These environments prioritize low latency, maximum security, and full isolation from external networks. Public cloud use cases include a startup hosting a customer-facing application using Amazon Web Services. A marketing team could rely on cloud-based productivity platforms such as Google Workspace for collaboration. A software development team might build and test new applications entirely on virtual machines hosted by a cloud provider. These examples benefit from agility, reduced upfront investment, and the ability to adjust resources as needs change. Hybrid cloud scenarios include a government agency storing public information in the cloud while keeping internal records on premises. A university might operate student-facing services in the cloud, but keep identity management systems on site. A retail chain could process point-of-sale transactions locally while using cloud services for analytics. Hybrid models allow separation of workloads based on sensitivity, performance, and availability requirements. Cloud bursting is a specific hybrid strategy where on-premises systems handle normal workloads and excess demand is redirected to the public cloud during peak times. This ensures service continuity without maintaining permanently oversized on-premises capacity. It is often used for seasonal workloads or unpredictable traffic patterns and requires careful network and resource coordination to work reliably. Data sovereignty refers to laws and regulations requiring that certain types of data remain within specific national or regional boundaries. On-premises and private cloud environments provide full control over data location. Public cloud services may allow region selection, but the legal definition of data ownership and jurisdiction can vary. Compliance frameworks such as the General Data Protection Regulation or Health Information Privacy laws can heavily influence the choice of deployment model. Disaster recovery and business continuity planning can be enhanced by cloud capabilities, which allow geographically distributed backups and faster failover. On-premises, disaster recovery requires physical redundancy and possibly multiple facilities. Hybrid approaches allow local restoration of services while also using cloud-based failover options. Regardless of deployment type, disaster recovery plans must be tested regularly to ensure effectiveness. The exam may include scenarios requiring you to match a business requirement with the most appropriate deployment model. These questions could test knowledge of cost structures, flexibility, performance, and availability. It is important to clearly understand the strengths and weaknesses of each model to answer accurately. Thinking of the difference as owning your own data center versus renting services can help clarify comparisons. Key glossary terms to review for this topic include on-premises, public cloud, hybrid cloud, cloud bursting, data sovereignty, and high availability. Linking these terms to real-world case studies will help reinforce understanding. Using flashcards or simple diagrams can also help clarify the trade-offs between models in terms of control, cost, and scalability. In practical roles, system administrators often maintain on-premises servers and secure remote access through virtual private networks. Cloud engineers are responsible for deploying virtual resources, monitoring usage, and integrating software-as-a-service applications. Hybrid specialists manage identity synchronization, data migration, and networking across combined environments. Understanding all three deployment models is essential for collaboration between infrastructure and operations teams. When preparing for the exam, compare each model using consistent attributes such as cost, control, scalability, and maintenance requirements. Identify typical industry use cases that match each model and review the shared responsibility considerations for each. Real-world examples will help solidify these concepts for both the test and professional application. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.